Hey there, Sevens. So I'm going to be using these ideas we had from the last activity, and I'm going to show you guys what I was hoping you saw on this activity. A lot of you guys had awesome ideas, and we really separated into two camps. There was the camp of people who are trying to use these ideas to justify their thoughts, which is great. Like, that's the correct direction to move. And then we had people who actually tried to physically draw the triangles and see what they could do, which is solid. This will be faster. But we will see the people who tried to physically draw things probably saw something that the people who used this didn't. So yeah, let's get started. Good. Here we have the first page and the setup we had. I was hoping you guys would go through here and say things like, angle B is 50 degrees, AC is 3 centimeters, BC is 5 centimeters. And I would look at this and say there are just two directions we can go around the triangle. It could be angle, side, side, going that way, or it could be side, side, angle, going this way. So in this case, I get angle, side, side, or side, side, angle, which is, if I look back here, it is not a congruency. What we saw is in that case, there are two possible triangles. So when I come back here, we can just say there's more than one possible triangle. That's what I would expect. We will come back and revisit this, and you'll see why in a minute. Good. Then the next ones, I would expect you guys to go through the exact same type of thoughts. So here we have side lengths of 9, 10, and 11. Well, I can label those things. So AB is 10, BC is 11, AC is 9. It's actually pretty similar to the triangle I have drawn. But that is side, 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 which definitely is a congruency, which means that triangle must be unique. There is no other choices. Next one, I was thinking here, you see we have angle, angle, angle. I could fill those things in, but we can see this is angle, angle, angle. And we know that means we could draw this little small triangle with certain angles, or we could draw a huge triangle with the same angles, like things just scale up. When we have angle, 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 it's like we call that a dilation eventually. But good, angle, angle, angle then produces more than one triangle because there's an infinite number of triangles that we could scale up or down to. And the final one here, we had AB being 4 centimeters, so 4 centimeters, BC 3 centimeters, and angle B 30 degrees. So just like in the first one, there are two directions we can go around this. I would get side, angle, side going that way, or I could go back this way and get side, angle, side. Either way, this last one ends up being side, angle, side. And if we look back at those congruencies, you would see it is a congruency, meaning there has to be exactly one unique triangle. So if you were going through the fast way using these ideas, that's what I would have expected you to see. But the people who drew the triangles caught one thing up here, and they're exactly right. Now, I like moving quickly and using math, I would have said 50, and AC is 3 centimeters, BC is 5 centimeters, angle side, side, and good, that's a more than one triangle because we'd have two possibilities. But if I do come here and look using, I'm just going to use GeoGebra to look at this. I have the same idea. We've got 50 degrees and angle B. AC is supposed to be 3 centimeters and BC is 5 centimeters. The problem is this needs to shrink to 3 centimeters, but in order to shrink this side, I would have to move this angle to shrink it. And so now I have the 3 and 5, but my angle here is off. So to fix that angle, I have to bring it back. It's obviously not possible. And so there were people, a lot of people who said this one is not possible, and I agree with them. That's a good catch because this didn't follow the easy rule we have. To have a nice rule for this one, we actually have to start trigonometry, which we will in 8th grade. So we'll have nice rules for this when we start trigonometry. For now, you just have to kind of draw the triangle and see what happens. Good. The last one is about this. We have these triangles, ABC, which is isosceles, with AB being 5, angle B being 48 degrees, and it's isosceles. Same thing with DEF. We know DE is 5, angle E is 48 degrees. And then we want to show they may not be identical. Obviously, these could be identical if we just use the same information, like maybe those two sides are congruent and these two sides are congruent, and that's identical, done. That makes this isosceles, and it all fits. And congruent, I mean like those sides are also 5. Those triangles would be congruent by side, angle, side. But if I back up, we want to show that they don't have to be identical. So if they don't have to be identical, I always just kind of make choices and then try to see if I can force them to happen. So one I could make is this one has those two sides congruent, and this one has those two sides congruent. If that happens, those triangles would be unique and they would be different. So let's just look and see if those triangles both exist. And here, come on. We've got angle B is 48, side AB is 5, and we want to make side BC be 5. Well, I can go ahead and measure BC, and BC is 5. I'm actually already there. So this triangle exists, and that's good. The only other question then is, does this other triangle exist, where I want this leg and this leg to match, like those to be the same, and to like be a different triangle than this. But I don't care if this one changes from 5. This one has to stay. So I can change, I can move this, and not if I don't grab the right tool. Come on. Sorry. Ugh. Okay, move this guy in. I want to keep that angle of 48 as much as I can, but I'll move in until these guys are equal. Boom. And 47.9, but you can see that that triangle exists with these two being equal, and they're different triangles, because in this one we had clearly 3.7 on these sides, and this one I didn't write down what the third side is, but they're clearly different triangles. So great, that's how you could show it. The other thing I had today is an intro into types of quadrilaterals. These are things that you probably know a lot, but I hope that we push you a little bit beyond. So different types of quadrilaterals we'll talk about today are going to be rectangles, squares, rhombuses, parallelograms, trapezoids, and kites. There are a lot. It's a big vocab day. But some of this vocab is easy, like rectangles and squares you've defined for a long, long time, but we will give you better definitions today. Classification criteria, we have the ways that we will classify rectangles are, quadrilateral types. Quadrilaterals have 4 sides. They will be classified by their number of congruent sides. Like you guys all know, squares have all congruent sides, but they're actually not the only one of these quadrilaterals that do. We'll also use the number of congruent angles and the number of parallel sides they have. So let's look at definitions first. Parallelograms and trapezoids are defined by the number of parallel sides they have. So you'll see that pop up. Rectangles and rhombuses are similar because rectangles have 4 congruent angles. Rhombuses have 4 congruent sides. A square has both 4 congruent angles because it's a rectangle, and it has 4 congruent sides because it's a rhombus. So good, that's pretty simple. And then a kite is a quadrilateral that has 2 sets of congruent sides, but is not a rectangle. So a rectangle had 4 congruent angles, and we'll see what that looks like, and how a kite could be the same, but it's not because of the way it's defined. So let's go look. Examples. Parallelogram, I said I'll go in red. So a parallelogram has to have quadrilateral, has 4 sides, and has 2 sets of parallel sides. So I'd have 1 set of sides if I just make those parallel. Great. And then the other set of sides has to also be parallel. So it means a parallelogram in the end looks like this type of thing in the middle there. There is the parallelogram. And you can see how they just look like they have parallel sides. So a trapezoid, on the other hand, only has 1 set of parallel sides. So I'll start with 1 set of parallel sides. And then the other 2 sides are not parallel. So I can kind of connect these however I want to. And then it makes this quadrilateral inside of there that is a trapezoid because 2 of those sides are parallel. So there's some definitions. A few more examples: rectangle, rhombus, and square. So a rectangle, I said I'd go in red. Rectangles, we all know, have 4 congruent angles. So all of those angles must be 90. we saw the angle sum of a triangle is 180, and I could extend that just right now to say around the outside of the rectangle, there are two triangles. So those have to be 180 and 180, which makes 360 degrees, and divided, it's 90 degrees each. So that makes sense, rectangle. A rhombus has four congruent sides. So if I draw any given side length, it has to have all the sides be equal to that. They end up looking diamondish. And I'm just marking them like that to say all four sides are congruent. And then the square has to have both of those properties. So I have to have all the angles be 90 degrees and all sides congruent. And we all know what squares look like. They are rhombuses, but they are also rectangles. Cool. So last example, a kite is a quadrilateral with two sets of congruent sides, but not a rectangle. So if I draw like congruent sides, let's say we have one side is going to be that length, and then another side is going to be this length. Okay, so I can start to put those together. I'd have a side like this, and then let's say we just put that next to the other side looks like this. Well, I want to make it not a rectangle, meaning that I don't want to complete it by doing this and this. I want something different than that. So what I need instead is to put that side here. And as soon as we complete this, you see why we call it a kite, because like it looks like a kite that you would fly in the wind. So kites end up looking, because that one's a little bit wonky, like this, where those are equal and those are equal. Those are all of the new definitions I have for you right now, but I'd like to go ahead and put them together. Like, how do they relate to each other? And we're going to use a Venn diagram to do it. So three that are obvious are rectangles, squares, and rhombuses. We know the way they work because we have rectangles on one side and we have rhombuses on another. And then we know squares are when both of those things occur. So I can go ahead and draw this in saying squares are rectangles and squares are rhombuses, and that's good. It makes them the intersection of both of those things. So which ones of these are parallelograms? If we go back and look, kites are not parallelograms because I can see this side is not parallel to that side. If these were parallel, then it would be. This guy is definitely a parallelogram, and this guy is definitely a parallelogram. And if you look at some examples of rhombuses, or if you picture kind of like taking a corner of a square and stretching it over, then you'll convince yourself this is also a parallelogram. So all three of these are parallelograms, meaning parallelogram then should be a big circle that goes around all, oh, whoops, that was not the right tool. Big circle that goes around all of them. Those are all parallelograms, great. Well, trapezoids we saw have only one set of parallel sides. So it's easy to say trapezoids are just not parallelograms, which means they can't really interact with the other things. And then the other question is, where do we put kites? Well, kites are not parallelograms because they don't have parallel sides. And so do they have one set of parallel sides either? And if I look back, I can see there are no parallel sides here. So, and I know my drawings are messy. So I end up with a Venn diagram that looks like this. Great. So this is our final Venn diagram we end with. This will probably be useful as you go through the assignment. And actually, if you know how to rely on this, your assignment will go very, very quickly. So best of luck, Sevens. If you don't know how to use this and go about the assignment, definitely let me know right away and let's chat. Have a great day. I'll talk to you soon.